The science of fog. Fog is one of nature's quietest and most mysterious weather events. It doesn't roar like a thunderstorm or swirl like a tornado, yet it can completely change how the world looks and feels within minutes. At its core, fog is simply a cloud that forms at ground level, but the science behind it is both fascinating and important for everyday life. Fog forms when air near the Earth's surface becomes saturated with water vapor and tiny liquid water droplets begin to float in the air. This usually happens when warm, moist air cools down enough that it can no longer hold all of its moisture. The temperature at which this happens is called the dew point, and when air temperature drops to this level, condensation begins. Instead of forming rain that falls from the sky, the water droplets remain suspended in the air, creating fog and reducing visibility. One of the most common ways fog forms is through cooling of the ground at night, known as radiation fog. After sunset, the Earth's surface loses heat, especially on clear and calm nights. The air directly above the ground cools as well, and if it reaches the dew point, fog develops. This is why fog is often seen in the early morning and tends to disappear after sunrise when the sun warms the ground and the air again. Another type is advection fog, which occurs when warm, moist air moves over a cooler surface, such as when ocean air flows over cold land or water. The air cools from below, causing moisture to condense into fog. This is common along coastlines and can persist for long periods. There is also valley fog, which forms when cool, dense air sinks into low-lying areas, trapping moisture and creating thick layers of fog that can last well into the day. Fog droplets are extremely small, much smaller than raindrops. Because they are so tiny, they fall very slowly and can stay suspended in the air for hours. These droplets scatter light in all directions, which is why fog makes it hard to see clearly. Headlights, streetlights, and even the sun appear diffused and hazy in foggy conditions. This scattering of light is also why fog can appear white or gray, depending on its thickness and the surrounding light conditions. From an aviation and transportation perspective, fog is especially important because reduced visibility can make driving, flying, and shipping dangerous. That's why meteorologists closely monitor humidity, temperature, wind, and pressure to predict when and where fog is likely to form. Despite its challenges, fog also plays a role in natural ecosystems. In some regions, fog provides an essential source of water for plants and animals, especially in dry coastal areas. Certain forests rely on fog drip, where moisture from fog condenses on leaves and drips down to the ground, nourishing the soil. Fog can also influence local climate by reducing daytime temperatures and slowing evaporation. Scientifically, fog reminds us how closely temperature, moisture, and air movement are connected in Earth's atmosphere. A small change in any one of these factors can turn clear air into a world of mist within moments. Understanding the science of fog helps us appreciate that even the quietest weather phenomena are governed by precise physical processes. The next time you see fog rolling across a road, a field, or a city skyline, remember that you are witnessing a delicate balance between heat, water, and air. Nature's way of showing how invisible forces shape the world around us. If you enjoyed learning about the science behind everyday phenomena like fog, like the article, share it with others and subscribe for more simple and fascinating science explanations.